There we go. Good morning. Hello. Forgot that I had OBS on this screen, even though I'm staring right at it. Apparently, it's that kind of day today, but it's also Friday. So happy Friday, everyone. Hello. How is your day going? I am looking forward to exploring Rapier2d. We learned about it yesterday, and it sounds like it might be interesting to sort of like help with any kind of like physics things that we're going to be doing. We've done bits of physics stuff in the past, but this would involve lots of like circles interacting with each other, which hopefully should be pretty simple. But then again, who knows? Let's see, there's a user guide. Let's use that. I'm probably only going to look at the rigid body collisions and forces. That's probably only what I want to care about. And I'm probably like really interested in like, how can I get this to work with BBECS too? There we go. Okay. Okay, so cargo, we're gonna create a new package, standard normal stuff, then bring in Rapier2d with whatever version, but we're gonna bring in and use SIMD stable. Now this is interesting. I haven't seen bin, like the binary before. I wonder if that's where it puts the binary, because that could be really useful for GGEZ stuff too. Let's try it. So here we have this directory. I think what I want to do is a cargo init. Then we're going to bring in you. Then we have this bin. Okay, let's try it. Name. So this is going to be our exploring Rapier2d. Exploring Rapier2d. So is this going to create a directory for me? Or is it just going to go here? I don't know. We're going to find out. So if I run this should be the good old hello world. So we do a cargo run. Oh, right. It needs failed to download an algebra. Interesting. I thought it would download an algebra for me. Or that might be due to all this blocking stuff. Let's try it again. Oh, caused by feature resolver is required. I mean, is that because I added the bin in? Here, let's see. If I take the bind bin away. No, okay, so that's different. Why can't you find it? Feels strange to me. Okay, failed to parse manifest at N algebra 026. I don't think this is going to help if I try to bring in an algebra, right? Zero 26. That 2. Okay, so it's that same version. Failed to download. If I put in something that I know works, so like ECS is ours. So if I run you, okay, that's fine. It's Rapier2d and algebra is not happy. Is there a am I missing? Do I need an older version of Rust? Couldn't read exploring Rapier2d RS. The system could not find the file specified, which would be this stuff, I think. So if I remove you, try you again. That, okay, so that works. Yeah, the bind, it didn't like this bind stuff. Yeah, it just says, okay, could not find the file specified. Probably because it's looking for it out here, when it's actually in target. I'm curious what mine is. It's gonna be binary targets are executable programs that can run after being compiled. The default binary file name is source main rs. Oh, really? Which defaults to the name of the package. Additional binaries are stored in source bin directory. Bear Cool, hello, good morning. Okay, I don't think that I need this. This one. Yeah, so they're using bind to like bring in example, but that's just they're naming their code example in source, and we're using main, so we should be fine without this then. Okay, back to you. This doesn't seem to be working. Now it's failed to parse manifest at the N algebra. Oh, so N algebra has a cargo manifest problem? Okay, let's try an older version. Yes, I know it's older. Build failed. That's not a good sign. Oh, okay. So my problem is the wrong version of Rust. I'm okay. I'm a little bit curious if I bring in GGEZ. Let's just bring in the latest version that we can use, that latest stable version of GGEZ. Let's stop show. Let's just update. So I know on Linux that there's problems with more recent versions of Rust and GGEZ, but I wonder if I can get away with if that elsewhere. Okay, so stable Rust didn't change. We just updated nightly. What is the latest? I guess 051 would be the latest. Rest up, default. Can I just do stable? Yeah, okay, I can. So that's that one. So then if I do a go build, let's just start bringing in GGEZ built with latest Rust, and let's go ahead and just set things up here. So what problems? I think our problems are the wrong version of Rust for Rapier2d. I'm pretty sure that's the issues we're running into. Maybe it's something else. Impl event handler. Maybe. There it is. Okay, so if we just do that, that's not really any problems. Rapier2d out of date or a nightly? It doesn't sound like it should be. But I had it an older version of Rust due to GGEZ on Linux. So I'm just trying to go to I'm trying the latest version to see if GGEZ latest works with latest Rust on Windows at the very least. And then we also had like a weird problem trying to compile latest version of algebra, which inside of Rapier2d, which I thought was really interesting and strange. But if we look at this, okay, so this fully compiled, so this is fine. Let's just do our impl. So I don't actually know if we need context, but usually it's a good idea to keep it in there. Also pull in, just because I want to make sure all these things are compatible with each other. Oh, you missed some? Oh, did it skip? Did it do the thing where it like just suddenly skips you to like present? I hate when that happens. When I'm watching on my iPad, My iPad is so old that it just starts getting farther and farther behind, even with good internet. I'd rather have listened to your answer than pause play. Oh no, so you missed my answer. Now I need to remember what I was doing, what I was saying. I think, let's see, what did I say? Our previous, you can check the VOD. Yeah, I don't know. It's early enough in the morning, and like today I'm not at 100% today. Okay, so let's do this. Let's head back to, wait, what are you upset about? Oh, context, bring you in. Import you. All right, so we're happy here. Let's do it here. Let's mode, alt. Don't know if I really care about this here, so I'm just gonna leave that the same. Setup. Oh wait, I know what I care about. It's like there's a name thing. And I forget what it's called. Is it not? It might be setup then. Oh, so GG Easy has issues with latest Rust. Yes, it has issues with latest Rust on Linux, from what I understand. But I'm just doing a really quick experiment just to make sure that I'm not wrong about that. Okay, so this is exploring Rapier2d. So we have a mute context, mute event loop. There's something to do about like something to do with like an X11 or Xorg or something, or maybe even some graphics thing. Can't remember exactly what it is. And it hit all of the game engines, but I don't actually think that that GG Easy updated with it. I think a lot of the other game engines have though. Let's see. This is context builder. That's what we want. Context builder. New game ID. You are build. Oh my gosh, come on, type. Stop hitting all the other keys on the keyboard. Yeah, it was a big thing, but like I think all of the other ones have updated. I haven't tested them out. I was just looking at like, I was just reading up on like the latest changes to Bevy last night, sort of like see where they are and if they've like stabilized a little bit more. They've got so many interesting changes coming. Why do I have that? I don't need that. Okay, so I need to, for build, bring in these things. Set up. Okay, so that gives us that. Then it's time for us to do that mute state new context. text. Okay, we can finally do the thing. Event. Gamepad event. No, wrong event. It's lowercase event, isn't it? Event, run, new context, mutable reference to event loop, mutable reference to main state. There we go. Except no. There we don't go. Oh, context. Right, you need to be mutable reference. That red was so hard to see. I wish that it was like in your face. Okay, so only our warnings. If we do a cargo run, we should get a box. We do. Okay, so latest Rust works with this. That means we should be able to come back to here and let's try this again. So let's see. Not star. We want actual latest version. So let's do 080. I'm going to let Rust Analyzer finish this check. I want to make sure that that works successfully. So you're over in Raylib and SFML. I don't think I've touched those Raylibs like those. Man, cargo check has taken a long time. $188 out of 682 after that much time? That is too long. Okay, never mind. I'm just gonna run this. We're gonna do a cargo build here just to see if we can. So far, good news. So I can't use Rapier2d with an older version of Rust. That's really good to know. What's a .toml? So .toml, it's a type of file. So it's a file extension for configuration files for Rust. It's basically yet another. Actually, so if you've heard of like YAML, which is like yet another markup language or something like that, which is like another replacement for JSON, that's exactly what cargo.toml is. It's basically, this is like a JSON type thing, except the syntax is just different. That's all really it is. And this gets used in conjunction with, what's his name? Rust to sort of like tell it what to do. So it's exactly like package.json, except different format. Okay, so we got to this part. Rigid body simulation. This is where we're going like today. Right, I need non-deforming objects, so I don't really care about that. I don't need a bunch of circles to go ragdoll on me. Okay, so this is our bare minimum setup here. So we have to have a pipeline, physics pipeline. Then we have our game loop where we have this pipeline.step, which means we need to store this pipeline away. Okay, I'm gonna move this over to the side. You over to the side. Come back here. Okay, so whatever we need in this loop is gonna be what we're running in update. So that means we have to store this stuff away. So gravity, okay, pipeline. We need the pipeline. So you're a physics pipeline. physics pipeline. Here we go. Volcanic popsicle. Hello, good morning. This is interesting. Awesome. I hope that it's interesting. Okay, so pipeline, are you used here? I don't see it being used here at all, so I'm just going to throw it right directly in here. Pipeline is a physics pipeline. New. Oh, afternoon where you are. Awesome. Well, good afternoon then. Okay, so then we're going to have this like pipeline.step inside of update. Okay, so next up, gravity, which is this looks like it's going to be an algebra vector 2. Okay. I'm probably going to have to add in some of this type of stuff into our ECS, like an algebra vector 2s, which now that we have those macros should be really simple. You've never used a physics engine that wasn't built into a pre-made game engine. I know, me neither. It's going to be interesting. Okay. And this library has a plugin to use in Bevy too. So once Bevy becomes a little bit more stable, we could, like, any learning that we have from this hopefully should translate over to that. And they have a 3D version too. So that could be really interesting as well. All right, so we have our pipeline. We want to create gravity, which is just a vector 2. So right now, let's just create that in here. So we have our gravity. Let's just call this a gravity force. And you're going to be a vector 2, an algebra vector 2 with a... Now, you don't say what that is, but I'm guessing that this... I mean, it has to be a F32 for us. So that's what we're going to use. So gravity force, you're going to be a vector 2 new, and that is the weirdest looking gravity. That's up. Why is gravity going up? Oh, you have no idea what the gravity... Oh, thank you, Chantilly. And also good morning. For the link to the Bevy engine. But yeah, Bevy is a relatively or brand new game engine in Rust. Okay. I am really very suspicious of this number here, but we're gonna try it just because I want to see what the heck they're doing with it. All right, we have that. Now what are you upset about? M1 expected 4 arguments. Okay, so vector 2, we brought in vector 2 new, expected 4 arguments. So F32 const array storage. So Rapier2d NA vector 2. Okay, so that is correct. There's no single canonical up direction in coordinate systems. Okay, that's good to know. I usually do it the opposite way because I usually, I guess, think about I guess I do it the opposite because I just think about it in pixels terms, not in terms of like the actual world is pulling it down. So I've always done it, yeah, differently. But also, hello, Ootsby, and welcome. No, positive gravity means positive amount of pull down. Yeah, I guess like they just think of gravity in different ways. However, I'm sort of concerned about what this means here. So you're okay here. But when I create a new vector here, like, first of all, did I just write this wrong? And did I bring you in wrong? I don't think I did. Yeah. Even if positive numbers are up in world space, gravity could still be a positive number if I want them to go up, right? So already we're running into a little bit of a problem here. I guess okay, I don't usually do this, but I'm gonna try this just to see if like we get a better everything from this. So starting here, just bring you all in, save you, bring you all in there. Let's not worry about this for right this second. So just looking at this, yeah, okay, so vector 2 is still having a problem. So what if I, oh, you mean gravity number is just amount of pull? I understand. Yeah, totally. What it just means is exposing myself to other ways of doing stuff is good because it expands my horizons. Okay, so let's actually bring in algebra. It's the same version that they have internally. So if we do that, and I don't want to take in this version of vector 2, I want this version. Import vector 2 from an algebra vector 2. F64. Okay, what if I tell you that you're going to be a vector to F32? No, it's the exact same problem. How come a vector 2 needs 4 things? Like, okay, so it needs a matrix. Okay. Where's the vector 2 type coming from? And algebra. We're about to go look at the documentation for it. API documentation and algebra. Want a vector 2. So we got this from algebra vector 2. I don't know if it matters that much. So here's, oh, look at that. Okay. Type vector 2 is matrix T U2 U1 and then array storage T21. Okay, hold on. Give me a better one. That's the only vector 2 we have. Danny Fritz, hello. And algebra generics are always like this. Why it have to be like this? Why don't you have, okay, why aren't you together? Did they change recently? Vector half? Yeah, that's what I want. Okay, vector 1. If I just look, vector 1 requires all these things too. These are, okay, these are types. These are types. So we're probably looking at a matrix, which I think implements it. So matrix. So base matrix. So here's all this stuff. Okay, so let's go in here. Everything is a generic over a generic matrix. It's too much. Oh, if I click in on this, doesn't seem to do anything, which is cool. Okay, great. I want a new. Okay, the generic matrix type has 4 type parameters. T for the matrix component scalar type. So like F32? So, wait. Like, okay, so gravity equals that. And if I just say, okay, for the type, I mean, do I just give it the type F32? Or do I give it like a number, which is like 0.0 F32? Okay, it figured out that's an F32. What if I actually just say F32? You're unhappy, so you need to be. Okay. R for the matrix number of rows. I want to. Yeah, okay, so if I do 2, if I do like 0.0, and then what was the one we were using? Still the same problem here. So wait, where did it go? Here it is. Okay, and then S for the matrix storage data. Okay, so T, R for the number of rows. I think matrix 2 is 1 row. So, okay, want 0.0 F32. I want 1 row. Why do you need to be a const? C for the matrix number of columns. These type parameters should go. We could try that. Is it in vector or new? I know, like it's so confusing to me. Why they would not do this? Okay, number of columns. We need two rows. Wait a second. One row, 2 columns. So wait a second. 1 row, 2 columns. And then matrix storage data, the buffer that actually contains R and C can either be type level unsigned integer constants. Okay, that's fine. Wait, data S. Help text is implying this is a 2x2 matrix. That's not. Okay. Okay, so vector 3 new. It's great that it doesn't give me much information for that. No, I'm unable to give their two floats because if I just do like a 0.0, like another 0.0 F32, it still fails because it's saying I'm missing these two things. Which is unfortunate. Okay, so if I just do, have I tried yelling at my computer? What are you doing? Just work. Also, wait, that compiles. No, it doesn't compile. I don't know what it wants for this. If I give it like just an array. Array is wrong. A tuple? No, is also wrong. Oh my gosh. Expected 2 arguments. And I supplied 4. Really? Really? Expected 4 arguments, found 2. Oh, and algebra. Why you do this? Why? When did you update? Why would you do this? Okay, 26.1. Uh, 0.26.2. Wait, where is it? Where's the version? Yeah, 0.26.2 is like the latest version. Are there not simpler vector 2s that you can use? I mean, in vector 2, you should just be able to make up the type itself. Yeah, I guess the problem is I don't know if they need something here. Like in his pipeline step, it needs like a vector 2. But I don't know if they're doing something like in it. Let's go. Okay, so this is pipeline.step. So if we head over here and we find step. So you need a vector with a real number in it. So vector n is a vector 2n. And the vector 2 is is this matrix thing. So yeah, it needs to be this matrix thingy, because they're not doing like an into or anything on it. They're just assuming it's a vector 2 from n algebra. So that's like, we're not gonna be able to get away from it. We need to use an n algebra vector 2. Nothing is making sense. No. Like, their documentation is just flat out wrong. And as far as I can tell, that's because n algebra is just flat out wrong. Can you look at the code for vector 2 new? Yes, let's head back to here. Let's go find you. Oh, it's in a macro. It's in a macro. Yeah, look at that. Square matrices, rectangular, rectangular. So it should be 1, 2. Okay. There we are. 1, 2. I don't understand here though. So like 1, 2, like that. Except now it's just saying I need to take. If you look back at vector 2 again. Type of 2, 1. But this is why people don't like I was fine with n algebra until apparently I used the latest version. Like, I was using an older version, I was happy with it. Okay, missing data structure fields, data and phantoms. Ah, great. Okay. Is there a default? No. There is no default also. Well, actually, there kind of is. Type annotations needed for this. Wait. What was that? Consider giving gravity the explicit type in algebra. Matrix T. Okay, so let's try this entire mess here. All right, so matrix T, where you're in F32. 2U size, 1U size. You're also in F32. Okay, got it. Gravity, vector 2. And if I store in gravity, are you happy? No? Oh, right. Need to tell it that it's a F32. Okay. This works. So we're gonna be doing just a little minor change here. Gonna add in no, I don't think that was the problem, because if I remove this, if I select you and then hit delete, I want you to go away. Oh, actually that works. Okay, never mind. You're right. That F32 was incorrect. Okay, so we have to do a default, and then I can mute it default, this gravity, and say gravity.x is equal to 0.0. Gravity.y is equal to 9 whatever. That's this thing. Can I bring new back in now? Sure, let's try. New, we're back to expected 4 arguments. So, no. Can I do new with nothing? No. So, default. So, cool way to create a vector 2. So what I'm going to do here is I'm going to create just a little teeny tiny wrapper around it. I'm going to call this vector 2, or S. It's not really a full facade pattern, but it's going to allow me to like not go insane with this. So pub function, what I want it to do is like create it in the same way, but it's going to return an algebra vector 2 from what I want to do. So I don't actually need, let's see, vector 2. I want this to be a pub struct vector 2. We're just going to be working on, let's see, I don't even need this. I'm just going to do an impl for vector 2. Pub function new. We're going to take an x, y. We're going to return a vector 2, which is going to be an algebra vector 2 with an F32 inside. So let mute. Our vector is going to be equal to a vector 2. So that's going to be this an algebra vector. No, wrong one. Not you. Also wrong one. N algebra vector 2 F32. There we go. And algebra vector 2 default. To help out with this, we're just going to return the vector. Then we can say vector.x equals x, vector.y equals y. Okay, so if I do this, I should now be able to call my own vector 2 from this. What are you upset about? Methods called new usually return self. Yes, I am well aware of that. I understand. I don't care. They usually return self. This has turned into an unusual requirement. All right, so back here, now what I can do is for this gravity here, we can do let gravity equal to a vector 2. Basically, it's this vector 2 vector2 new 0.0 like 9 dot negative 9.86 or whatever we wanted it to be. Yeah, 9.81. And then that gives us back what we want. So that should help us out a bit. Make it look nicer at least. Jeez. Peyton Rules, rating with a party of 16. Welcome, welcome, welcome. Hello, Peyton Rules and Raiders. How was your stream, Peyton Rules? I was watching a little bit of the before I was lurking before I started my stream. And it looked like there was some, you were getting some interesting things on screen, like having your character run back and forth, moonwalk backwards. You know what? We haven't had a chance to play with this yet. Let's see how it goes, because I'm really interested. Nope, this one. Documents, codes. Where did I put the? That's what I want. I want to try this one for our new raid game. It's pretty fun. It's Friday, so Quinn joins for a bit and played some games too. Oh, awesome! What games did you play? Oh, new version of Rust. We'll see if this works. Yeah, so you're doing state machine type things today, which sounds like the state machines always sounds interesting and like are much funner to do in Rust, I feel. I assume you're using enums for it, unless it's not a finite state machine. Hey, it works. Okay, so this is a game we made previously. It's we use these games whenever we get raided. I'm gonna play as long as I can, and you all can join in by just chatting and saying hello. So just a hello brings us in, and then you can give a strategy, and I will see how long I can survive while also reading chat. You're using enums plus structs. There's a good blog on these, but you're struggling to find an interface that you like.
Reinforcements out arrive.
Yeah, like having to wrap around it and like create whatever system you want. Ah, nope. Okay, died. 4 lives left. I got plenty of lives. Beginning of every level, that's where it's the most dangerous. And like it goes from, oh, this is fine, we're winning, we can go forever, to, okay, we're dead in 3 seconds.
Firing randomly. What could go wrong?
All right, level 7. 1 life left. I'm just firing randomly. Ooh, okay. No, level 8. We got to level 8. Did you process the voice to sound robotic? I don't think I tried to, but I didn't like do anything with it. I just opened up like Audacity and just like recorded myself and just went with that. I'm not trying to sound robotic, but it ended up sounding kind of robotic, which I think works pretty well. So yeah, we make these type of interactive games and like stuff and interesting things on stream here. We almost always work in Rust. And yeah, today we're exploring Rapier2d, which is a 2D physics engine that we can use in other game engines. So I'm trying to use this in GGEZ, and we're running into like fun problems, like for example, Vector 2's not knowing how to create, so I had to just create a little facade over it, which is fun. So continuing on, now we have this pipeline. You're this pipeline, physics pipeline. So we can then store that away. And we need to just keep all of these things, just like store them away here so we can then use them in update. So that's the next thing to do here. So you are integration parameters. Would your default okay, broad phase, narrow phase, interesting. Okay, so wonder, I kind of want to just all right, let's you go to the end, colon, go to there, and there's comma. Okay, there we go. Then we create you, and so then all of you, so integration, then we have broad phase, narrow phase, bodies, colliders, joints, CCD solver, physics hooks, okay, interesting. We ignore physics hook and contact events for now. Okay, so we don't need to worry about you. Okay, so then we have in our main game loop, we have a pipeline step and we pass all this stuff in. Okay, so we would do a self.pipeline.step, and then for each one of these, it'll be just a reference to self dot. Come on, stop. Go to the next one. Self dot. Oh, except it's reference. Oh, I lost it. Oh, but okay, wait a second. So we have colliders. Hold on. Colliders, joints, and CCD solver. Okay, so we have that up until here. But then after that, we have hooks and events. So what do you care about? You need this to just be whatever this is, empty. So I guess I can create you directly in here for now. Physics hooks and event handler, okay. And you also need to be a reference, right? Oh, you all need to be mute. Okay, so reference, and then the rest of you mutable reference. So reference. The rest of you are mutable reference. Then You are back to reference again? Yeah, back to reference to physics hooks. Reference to event handler. Yeah. Okay. All right. So if I run you, like, we shouldn't see anything besides just the black window. Okay. So that should still be fine, but it's running a single step over and over again of like absolutely nothing. Okay. Is responsible for executing the whole simulation collision detection as well as simulation of physical phenomena like gravity. All the actual useful simulation related data are stored in the arguments of physics pipeline step. So I can create a new pipeline every single frame if I really wanted to. I'm going to figure it. Okay, it contains parameters to configure it. That makes sense. Broad phase does the AABB based collision detections. That's good. Narrow phase does precise contact point. So I don't care about these. I'm going to care about broad phase probably. Rigid body set contains all the rigid bodies. Okay. That's what we're going to care about. Then we have the colliders. All the joints. So I'm not probably going to worry about these two, just the rigid bodies, I think. Continuous collision detection, I don't know if I need that. The physics hooks can be used to modify the default behavior of the physics pipeline, like filtering what collision pairs are valid. Okay, I don't think I need that. Event handler will collect all the events generated by the physics pipeline. Oh, so we can like debug. Probably get a list of what happened. Each call to pipeline step will advance the simulation by a time equal to 1/60 seconds, which is a good default. So in order for us to like ensure that we're doing that properly here, let's do a while timer. Check update time, context, and then 60. So this will ensure that we are that we're only running this once every 1/60. What 16.66 milliseconds? I think you'll need colliders to go with my rigid bodies. Okay. I'm just sort of following along the book too, so we'll figure it out. Also, hello Rizix. My understanding is that rigid bodies define mass, collider define shape. Oh, okay, that actually does make sense. Because like one of them is going to be affected by gravity, the other one's going to affect with like colliding with each other or like the platform. Note that we are free to replace the pipeline by a fresh instance whenever we want, but we can't do that with everything else. Okay. Rigid bodies. A rigid body is the simplest type of body supported by Rapier. It can be seen as the aggregation of a position, orientation, and mass properties, so rotational inertia tensor, mass and center mass. It does not hold any information regarding its shape, which can optionally be specified by attaching one or multiple colliders to it. A rigid body with no collider but a non-zero mass will be affected by all the forces the world is aware of, including like gravity, for example. Okay, let's create a rigid body. Following example shows all the possible setters that can be called to customize the rigid body being built. The input values are just random. Okay, so So using this example as is will not lead to a useful result. Thank you very much for that. Okay, so builder for a static rigid body. The best type of example are the useless ones, right? So rigid body builder, we're going to bring in from Rapier2d dynamics and build a dynamic rigid body builder with a new static from dynamic. Okay. We're going to build two. Oh, we're going to build one of each. So a new static, a new dynamic, and a new kinematic. Oh, and then. Okay, so they're basically just showing us, hey, guess what? There's 4 ways you can create your rigid body. However, we're doing it this way. So they're using body stat. Okay, so you could do new, pass in a body status dynamic, which would probably be the same as this. That gets us the rigid body, and then they can do all of these things to it. That builds and gives us the rigid body. All the properties are optional. The only calls that are required are the rigid body builder, new or whatever. And then build to actually build the rigid body. Typically, the inertia and center match is automatically set to the inertial and center match resulting from the shapes of the colliders attached to the body. Okay, so that's where it is. We need the body and the collider. So if I were to just do this one, let's throw that up here. Haha, except we need a new vector 2. We know how to deal with that. Vector 2, that. My vector 2, which is their vector 2 too, but it, oh, am I gonna have to do the same thing here? Oh no, we just pull this in. Import you from algebra. Okay, pull you in. Pull you in. Okay, so this gives us a rigid body for us to play with. The code from the example works fine for you. It's just only Rust Analyzer complaining. Oh, it's just Rust Analyzer being poopy. See, this is what I get for trusting Rust Analyzer instead of just running it to see what the real error is, which in this case is none at all. Cool. So I have to basically do this entire facade pattern type mess just to make Rust Analyzer happy with me. In algebra with break Rust Analyzer takes generics to the extreme. Okay, so that makes a lot more sense. I don't want to have to switch over to like RSA, RLA. Oh man, I forgot what it's called even. It's been that long. So let's actually store our body. So you're a rigid bod. You're a rigid body. That. Oh, append it to bodies. You're right. We don't actually put that here. We append it to bodies. So here's the bodies. So we take this. We need you. Okay, you're mute. So we need bodies. Dot. Put. So how do I put it in bodies? Insert. Insert. This is rigid body. I probably don't care about that handle. Because like once it's in there, I just wanted to go through. Once the rigid body is created, it must be added to a rigid body set. A body set is okay, so we just did that. Upon insertion, the body set will turn a handle to the rigid body. This will allow us to get a reference to this body later if needed. So I could throw the handle. What's the handle? What type are you? Okay, it's a type. It's a specific rigid body handle. That's an index. It's a tuple type with an index. Okay, whatever that is. No two bodies. So that I could potentially just store the indexes or like the handles in ECS. Maybe. Any body can have one of three different statuses identified by body status enumeration. Dynamic. Okay, you're affected by external forces. You're static, you can no longer move, or you're kinematic, meaning that you can be hit by others. Kinematic is like a moving platform. Okay, so it's like, you know, it's like attached to the world and moving around on an arm, and so when people hit it, it's not gonna be like flying off the screen, whereas dynamic would be. Okay, got it. I probably just want to focus on dynamic then, for like my use case. Colliders represent the geometric shapes that generate contacts and intersection events when they touch. A collider is built by a collider builder structure following the builder pattern. Okay, so same thing here. So many. I want a ball, I guess. Is that a size? Radius, okay. That would make sense. Let's create this using this ball. So collider builder ball. So that collider equals collider builder ball radius. Exactly. So, okay. Let's do the radius. Let's do a 10 radius. Okay. And then when I draw that out, that should make sense then. Then we're gonna probably insert that into the colliders. The engine is in meters, right? I have no idea. It's a good question. I don't remember if it told us. Negative 9.86 is meters, you think? So that might be really, 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 really big then. Once the collider is created, it must be added to a collider set. So it's the exact same thing. We added to collider set, and then we're going to have the handle. So in this case, we have the body, and now this is the back. Body handle, and then we're going to do a collider handle equals colliders dot insert collider okay, this is different. A collider set is a container that maps a unique handle to a collider. Okay, so parent handle You're not creating that anywhere. Wait, where do I get the parent? Upon inserting a collider, it will be attached to the rigid body specified by its handle, parent handle. That's the body handle? Rigid body set? Is that this one? No. They've never created this variable before. So like suddenly passing it in. What are you? Damn, if you get this working, all you need is a visual level editor and you're set with who needs game engines? I mean, this is the game engine, but yeah, I agree. Okay, what are you and what do you need? Rigid body set. Parent handle is a rigid body handle. Okay, so we got that one. That's the body handle. So I think that's correct. But then these is a rigid body set. It's not that. Rigid bodies. Okay, it's bodies here. Oh, so it is exactly that. Expected a collider, found a collider builder, because we need to run build. Like that. Okay. And then you, mismatch types, expected a mutable reference. Okay. Okay. So now what? One of the most appealing features of the physics engine is to simulate articulations. Not what I'm going for. Okay, hold on. How do I tell you what your location is and all that stuff? Is that position? Okay, so our rigid body, we have our position here. It's at 1, 2, whatever that is. I don't know if that's like pixels on the screen or if that's like some other map of where we are. So if we run this once, so if I run this, we do one step of this. I then want to know what happened to everything. I don't know what this needs to be. Event handler. Event handler? It's a Dyn event handler. Is it like throwing things in here? Can I like debug event handler? Maybe I need to turn it into, it doesn't yell at me. So if I run you, okay, it's just an empty tuple. So that's not what I want. Can I debug a reference to self dot bodies. No. Oh, okay. So rigid body set cannot be formatted. Okay, so I can't do that. Self dot bodies dot. So here's this get. And I need the handle from it. Is there anything else that I can get? Like to get for each active dynamic body mute. I can iter through them. Okay. So you can do for body in self dot bodies dot iter. Gives me a rigid body handle and a rigid body. So in this case, let's try debugging the so we have the handle and the body. Try debugging the body. Stop. Okay. So we have this, it's like 3 and negative 14. Oh, there's a lot of stuff in here. Is there a location? World coordinates. Okay. Okay. World coordinates point. So body dot? No. Okay, so I want a rigid body. API. Rigid body. The world space center of mass of the rigid body. Is that public? It is. Okay, so I can get world com. So we can just look at this. We run you. And quit you, and we can see that this is changing, we see. The X and the Y is changing? The 0 is going up like that. So if I wanted to draw this out, let's do let mute builder equals mesh builder new. So we're gonna create that. Okay, so then in between here, we're gonna do this entire loop thing. So we can get that body com and turn it into the points. Now in here, can we see you're a point? Of course you don't tell me any good information about it. We'll have to figure that out. Okay, so body dot worldcom dot x. So let x equals that. Okay. So then so then our location is equal to x and y in an array. It's unknown. It's gonna figure that out soon. They have to be F32s. So then I want to create a circle. Is there a size on here too? Radius body dot. What else do we have in here? We have mass. We can just tie it to the mass. But I don't know, like, don't have like necessarily a super good size. Maybe mass, but like mass and radius do not have to be tied together. So let's just set you to be something like 10 for right now, and you'll deal with it. So then we're gonna do our mesh builder. We're gonna create a circle. Our point is gonna be the location. The radius is gonna be radius. Tolerance 1 at 0.1, and color will make you just white. I'm surprised I didn't give it the type there, which is gonna be a little bit disconcerting. Okay, so then we come in here and we're gonna do a graphics, draw, and the context, and a reference to the mesh, drop params. Oh, yeah, location is set there, so drop param. This can just be the default. We don't care about you. Then we go. So if I run you, there, our circle was in the top left, and it sort of just went up. If we head back up to here, our position is like 1 and 2. So if we set this to be, I don't know, 500.0, 200.0, now we have our circle over here. So we can figure out where it is in the world. Size-wise. Our collider we have as the size here, but we also need like the size here, which I don't know if we have. The angular velocity of this. Where is it in the world? It's next to Carmen Sandiego. Oh man, that show. I don't like. I used to watch that show all the time as a kid. Let's see. So if I create another one of these to insert, and I have them going in the opposite directions. Oh, Where in the World is Carmen Sandiego was a show a long time ago. Oh, there's also the games. Yes, we had those on C. Was it even CD? No, it was a floppy disk, wasn't it? That was way a long time ago. They have a card game now? Oh, okay. I didn't realize they had a card game. Yeah, that game was old. It was awesome though. Okay, so if I reverse this to 9.81, now it falls down. And look at that, it's falling faster and faster and faster over time. What I don't necessarily have, and I'm running out of time, but let's see. If I make a static rigid body and just like put that below it somewhere, then theoretically it could collide with it. Like if I put a second ball and I make it static, which means that it would not be affected by gravity. Can I cut, okay, so let's do let static collider equals collider builder. Oh, but we need a body handle. So we need to build a body too. So if I do like let platform equals, these are rigid body builders. So rigid body builder. This is just new, but I want body status. I want like a static. I guess new static is what I want. We're gonna build you. So just stay. Do I need to give it like a better position? I don't know. So platform and then a collider builder. Let's just also have you be a ball because it'll be, you know, everything that I'm making is just a circle in here. We'll make you 10.0 also. We'll build you. So that can do that. And then we do colliders insert there. And let static handle equals colliders insert. Okay, so you're gonna be our collider first, so it's static collider. The parent handle is a I don't have that because we need to insert into here first. So we need let platform handle equals bodies insert platform that. So then in here we insert, you're gonna be the platform handle and then a mutable reference to the bodies. Oh, did Netflix bring back the cartoon too? Oh, that would be interesting. So if I just do that, but now it's a static one, I'm curious where it goes in the world because I didn't give it a specific location. Okay, up there in the top left, and notice it's not falling down. So that makes sense. Now, if I want to set this platform to be in a very specific location, can I set your location here? So like position, you need to be this isometry new, which gives it a vector 2 new. So we start this at 500. Let's start at the same 500.0, but we'll do it down at like 300.0 down. And I don't need to have an angle, so you can just remain the same. So if I just do that, oh wait, we got an error. Vector 2 vector2 new. Okay. If we run this, now that ball is sitting here, let's see, can they... Look at that. That was actually pretty cool. With, we're able to get balls to like actually, with physics, hit each other. So we have a platform like that, and it slides off. Oh, that's really cool. So this this gravity feels really like high, but if I want you to be like, I don't know, 30, you missed it? Here, I'll run it again, both higher gravity. I mean, that's slightly faster, but I don't know how to make it so that it like bounces off of each other a little bit better. I don't know if that's the collider we have to tell. Like, okay, you're a collider. Oh, okay, we have like friction, density. Sets the uniform density of the collider of this builder will build. So whatever that is, nope, that didn't seem to do anything. We can have like a really high gravity. That just made it happen faster, but it didn't necessarily like help at all. I guess like there's things that we can do to like play around with it maybe. We would want to look at, let's see, rigid body. Oh, effective mass. Rigid body mass. Okay, so we also could like in our rigid body that create for this thing. Huh. Effective INV mass. Huh, look at this. Mass is crossed out. If I do something like 0.5, deprecated, renamed to additional mass. Additional mass? I guess it's being set somewhere else? It's not like getting it to bounce, but I don't really know what I'm doing here. So I'm just sort of like playing around. Density, I don't know if like that needs to, oh, this is the static collider density. That might be a problem too. We might want this collider to have its own density of like, I don't know, 0.01. Okay, that was interesting. Is 1.0 default? It is. Okay, so if I do like half of that, 0.5, bounce is probably restitution within collider. Okay, so we have collider, there's a restitution, F32, so let's try 10, just because. Oh, wait, there's gonna be an error. Oh, whoa, what happened? Hold on, 10 is too much. Let's do 1.2. Look at that. Oh, that's great. Also, why is it going to the right? I guess it's like the positioning, it can't be exactly center. This is really cool. So if I do restitution of 1, is that no bounciness? No, they're still bouncy like that. But we're bouncing now. So we can have multiple of these together. We can just throw them together and they're all gonna like bounce around. The center of mass might be on the right-hand side. Oh, you might be right. Center of mass. Now, what happens if I don't add additional mass? I don't know how to set the center of mass. But I have no additional mass there. In the Rapier demos, he definitely bounces bodies on top of each other. Okay, so it's possible to do. So that's cool. So there's like obviously things that I can do. Angular dampening. There's so much interesting things we can like look into, and like numbers we can play with. Let's see. So what did we call that? That was restitution. That happened here in the collider. So we have like density, restitution. There's like a delta. We can have friction, mass properties. Oh, set what the shape is. Huh, interesting. Okay, so cool stuff for us to build with. All right. So I think though what I'm gonna do is I'm gonna leave it here for now because it's 8:46. I do have to start working in less than 15 minutes. Restitution is kind of the velocity multiplier when colliding. 0 means no bouncing. 1 means no speed change, but direction does change. 10 means go 10 times faster. Okay, that's good to know. So if I were to make like a billiards game where you have like two balls coming and hitting each other, that's where I can set, oh, they bounce off in this sort of like interesting direction. That's really cool. So this actually unlocks some cool things for me. All right. So there's more for us to play with, but I would guess like that our next, the next thing I want to do is like put a whole bunch together and just sort of see them interact. Like maybe create like our, create our platform. It doesn't have to be a ball. Rigid body is just a new static. Like, can we do a width? Don't know how to like have like a size. That's just a position. Is this just like a nail? Like a 1 pixel nail? The starting velocity of the body is slightly to the right. Oh, that would do, oh, angular velocity. Okay, never mind. Linear velocity. There we go. So I think this is actually a pin. Angular velocity is a spin. Oh, okay. So if I turned on this angular velocity again and I have it touch this, will it like spin off because it's slightly spinning? It does. Okay. So yeah, we can do all sorts of cool physicsy stuff with this. What I don't know how to do is like turn this platform body into a, like, not a rectangle. Oh, because it's the collider builder. So this is that. The collider builder for static collider would have to be a, like, a rectangle or a box or something. We have ball, cuboid, polyline, triangle. Am I making pachinko? I mean, potentially, sort of. If you put one restitution, it'll bounce forever. Oh, that's a good point. Yeah, because it won't lose any data, any information. Or it can do like 0.999999, it'll bounce for a long time, but eventually stop. Okay, I'm not gonna worry about this right now. I'm gonna put you back. And if we go back into restitution here, let's do 0.999. Oh, that was build, not run. Interesting, even that amount just never changes. And 1.0, now that was ending. So I think maybe this density is ruining things too. Then it should bounce forever. Definitely there's some like mass being absorbed, like some absorption happening. I mean, there's so much cool stuff that we can play with here. Friction, there's friction. You're right. I'm not telling it, but whatever default friction it has is interesting. But yes, I do have to head off to work. So what we're gonna do, well, first of all, I'm gonna go ahead and end the YouTube video that we're recording here. So next time in the next YouTube video or next stream also, what I plan on doing is continuing to play with this, but like getting many balls together and like having them bounce off each other and see like what is our, what considerations do we need for having a whole bunch of them together? What happens when I have like, you know, 100, 200, 1500 of them all bouncing off each other and falling down. Friction is when shapes are colliding and moving while colliding, so I don't think friction will help here. Okay, so it's probably something else. All right, so for those of you in YouTube video, I will see you in the next video.